All right, let's talk about something you've probably typed 1,000 times without even thinking about it. I'm talking about NVSENDL. Now, on the surface, this seems like a super simple question, right? But the answer? Well, the answer is key to understanding how your code really works under the hood.
In programming, you run into this all the time, especially when you're starting out. You find two completely different ways to do what looks like the exact same thing. And that always leads to a great question. I mean, just look at this. On one side, we've got our good old \n. On the other, we've got endl. And the result? It's exactly the same. They both just move the cursor down to the next line. So what's the deal here? Why have both?
And that right there, that's the million-dollar question, isn't it? The people who design these programming languages, they're not just throwing things in there for fun. They don't add extra stuff unless there's a really, really good reason. There has to be some kind of invisible difference, something powerful going on behind the scenes. And that's exactly what we're going to dig into.
Okay, so to get our answer, looking at what just pops up on the screen isn't enough. We have to go deeper. We need to pull back the curtain and see what's happening backstage every single time you tell your program to print something. And that brings us to this idea of the output buffer.
So what on earth is an output buffer? The easiest way to think about it is like a waiting room. It's a temporary holding spot. Before your text actually shows up on your monitor, the program sends it to this little waiting area first, kind of getting everything lined up and ready to go.
Now, this whole process usually happens in the blink of an eye. It's so fast, you probably don't even know it's there. But, and this is the important part, understanding this hidden little mechanism, that's what separates good programmers from great ones. It's how you really level up.
And believe it or not, the entire difference between N and endl comes down to how they treat this waiting room, this buffer. It all hinges on one single action, something called flushing.
Okay, this table makes it super clear. Look at the first job. Inserts a new line. Both of them do that. No difference. But check out that second row. See how N line has nothing? And L, on the other hand, has a second job. And there it is in bold. Flushes the output buffer. That's the whole secret.
So what does flushing the buffer even mean? It's basically kicking everyone out of the waiting room immediately. It's telling the system, hey, whatever text you're holding on to right now, I don't care if you're ready, just push it all to the screen, right now.
Let's look at N first. It's the patient one. When you use it, the text goes into the buffer, and it just chills. It waits for more text to come along. It's happy to wait until that buffer is totally full, and only then does it send everything to the screen in one big, efficient package.
But endl? Oh, endl has zero patience. It puts a line of text into the buffer and immediately yells, "Get it out there! Flush!"